Okay, whenever you're ready.
Good afternoon, everybody. I'm here to talk about the Guido Van Robot project design review. And these are my colleagues, Bryce Prescott, Mike Vath, and Zach Taylor-Warren. And we're going to go over everything we did, how it worked out, and the things we've learned. So today I'm going to talk about marketing. We're going to talk about an instruction manual, our methods, and the experimental analysis. This project is very adaptable to all grade levels. Everything except for grade levels under 5th grade. But everything else from 5th grade to 12th grade is very adaptable. When we did it, we had a keyword base of only 3, and we expanded that, or we could expand that to a keyword base of about 12 if you need to go up to like 12th grade or something. Another way to change the project for older children is to make it harder, a lot harder mazes. You'll see some mazes later by my colleagues, and they will show you some of the harder mazes and some of the easier mazes that we had. And since students are not as developmentally below 5th grade, we don't suggest doing this project for 5th grade or below 5th grade. Most teachers will accept this project. I think most of them will think this is a really good project and good at teaching a lot of things that nobody has, or that a lot of teachers don't have skills in, like programming. How many of you guys took CS 135? Pretty much everybody. And if in 135, if you would have been using a program or a video game to do all the work, how many of you would like the class better than doing reports? Only 2? Well, so the kids loved it. They thought it was amazing, and we have some thank you cards to prove that. But the kids loved it, teacher loved it. Nevada legislator, as you can see, they have a curriculum just based on computer and technology, and this is where that fits in. And you're probably asking yourself, why should I use this project? Well, the first reason why you should use this project is it's very easy. We have a step-by-step instruction manual that tells you how to set it up, how to download the program, how to do everything you need to do. The second reason is it's cheap. It's free, pretty much. You just have to have a computer and an internet port. If you have that, you can download the project, you can download all the files that you need and everything else. And finally, as our slogan says, give your students fire for the future. So going into the job interview, they say we could program a little bit, we know the basics between it, and we can learn more based on that. Now I'm going to turn it over to Zach, and he's going to talk about the instruction manual.
Thank you, Rick. My name is Zach Taylor-Warren. I'll be talking to you today about the instruction manual. Basically, what we included in our instruction manual was a breakdown of the entire project. And we also included a CD with all of the necessary files that the teacher will need. So that breakdown of everything we need to know. The teacher needs to be familiar with what computer science is. That way they can give their students a basis of learning and a basis to start from to teach their students about what the project is going to be for. It also goes over what Guido Van Robot is. It's a free program that is available online, and it describes each of the necessary commands for the project. Things like move, turn left, pick beeper, put beeper. And we also go over some of the higher level command structure like loops and conditional statements. We also included possible maps and ideas for the project itself. This is a very adaptable problem, and we've given them a tutorial for world creation for the students. For the purposes of our project, we provided all of the worlds, but again, this is a very adaptable project. You can ramp up the difficulty as necessary or decrease the difficulty if need be. And also, for all of the included maps, we've given certain command lists that will solve the problem. That way the teacher understands very concisely how to do it, so that way they can answer any questions that the students might have. I want to give you a quick example of what a higher level possibility for that solution is. Again, these are all included in the instruction manual to decrease any questions that the teacher might have. For instance, we have a maze. It's got 2 possible solutions, and the solution implemented here is a follow the right wall until you reach the end of the maze solution. Again, we didn't use this for our 5th grade students. It's a little bit more complex than we were looking for. But again, if you ramp this up to the 9th grade level or whatnot, this is something that's very doable by those students. Thank you. I want to turn it over to Mike, and he'll talk about the methods of our project.
Thanks, Zach. My name is Mike, and I'm here today to talk to you about methods used to implement our project into the classroom environment. We had no baseline data, so we took several steps to minimize risk and give us time management. We restricted the number of commands to complete the maze to just a few to keep things simple. We had increasingly difficult mazes in case some students got the concept really quick, it would slow them down. And we made a classroom visit prior to the presentation to make sure the computer ran the program and that the projection screen worked. How many here think that computer science is exciting? Okay, that's not me. So we knew to keep our presentation brief. We gave an overview of applications of computer science, things that kids are familiar with, and then we described what computer code was and why it was important, and most importantly, we gave an animated demonstration of how the commands moved Guido Van Robot around the maze. For our project materials, we created handouts that had mazes that were exactly the same as the computer program, so the students could fill out their commands and we could enter them into the program. Obviously, we need a computer running the code, and a projection screen is an option so that more students can see what's going on. To execute our project, the students brought their code up to two of our group members, who then entered it into the code editor, and we executed the program step by step until it was completed, or if there was a failure, then we helped them debug the program to keep certain students from getting ahead. It kind of kept everybody on the same level of playing field. The lessons we taught were some introduction to analytical problem solving, the importance of accuracy when communicating with machines, and the concept of debugging. We really didn't have that planned, but it ended up going that way. We gave them a sense of achievement for every level of maze they completed, and as we were walking around the room, if students weren't participating, we encouraged them to get involved with the project. Next, I would like to turn the program over to Bryce for our experimental analysis.
Thanks, Mike. My name is Bryce. I'm going to talk to you today a little bit about our experimental analysis. Some observations that I made were that each member of our group took a role during this exercise. Ray and Mike, they helped the students while Zach entered the code of the computer, and I dictated the code to Zach so he could type it faster. The experiments was a success in our criteria. Our criteria was twofold. One, that we would introduce them to some limited computer science concepts, and secondly, that they would gain desire for it. And as proof, I have these cards because they really liked it. They gave us cards. Maybe they were forced to, I'm not sure. But I think that they liked it. The teacher told us that she really liked the whole presentation and exercise. The one thing she didn't like was that we only had one computer, her computer, and there was a line forming. The students, as you can see from the cards, they really liked it, and that's basically the feedback we got from them. So we learned that one computer was definitely not enough. We had theorized that they would all get done at different times and stagger up, but instead they all got done at the same time, and the long line formed, and they just had to wait, and they were bored, and it was very stressful for us trying to get them through that line. The source code was projected on the screen like this because we wanted them to see the robot moving around the maze and picking up the things and see it work for excitement. One thing we didn't think of is the possibility and the temptation of cheating because the code is right there. I mean, it's a good idea to put the robot on the screen, but probably not the code. The roles were not well defined in our experiment. We just automatically took the roles. So our recommendations for anyone attempting this experiment would be to use multiple computers, laptops, and on those laptops take one team of how many people, we had teams of 2, and run them individually so there's no temptation of copying. And define the roles of each group member ahead of time instead of just staring at each other and kind of guessing. And we had instincts, and our instincts told us to do certain things, and that worked out fine, but we should probably have talked about it more. We started with an example that kind of gave a tutorial on how to do it, but I think we could have done a little better in giving more lengthy tutorial. And we created 3 lessons. We probably need to create more, and I recommend for anyone doing any other grades to create more difficult incremental lessons. So we talked to you today about how to market this idea, the instruction manual for using this idea, the methods for using this idea, and the experiment and analysis. Any questions?
I have a question for Mike. How many mazes did each of the students complete during your competition?
Thanks for that question, Eric. It's a very good question. The question was, how many mazes did we have prepared for the students? And we had 3 mazes, and one particular group screamed ahead, and Zach, thinking on his feet, actually had the students do that maze backwards as a 4th maze. So we had 3 prepared, and probably could have used another one. Thank you for your question.
Questions for Raymond. What were the 3 keywords you taught the students? And if I was going to do this for older students, what are keywords that the younger students wouldn't understand that older students might?
The 3 keywords we taught them were turn left, move, and pick up beeper. And if we were to extend this to 12th graders or something, we'd add in loops, as you saw in Zach's presentation. We'd also add in if-else statements and stuff like that, maybe variables, something where they have to keep track of how many meters they pick up. So thank you for the question.
Right. You said the students were waiting online for the computer. Did they have something to occupy themselves with while they were waiting, perhaps?
Thanks for the question. The question was, when the students were waiting in line for the one computer connected to projector, did they have anything to do? The answer is unfortunately no, and they got bored and rowdy and started saying to each other, "You're cutting," all those sorts of things. So it would have been better to have multiple computers.
Ryan?
My question's for Zach. Where can I get a copy of Guido Van Robot if I want to use the program?
It's a great question. SourceForge has a website dedicated to Guido Van Robot. It's an open source project. The easiest way to get to it is to Google Guido Van Robot, and it's the first hit that you'll get from that search. Again, it's all open source, so if you're really savvy, you can kind of modify it to fit your needs. But again, it's perfectly acceptable for the needs of the design project. Thank you.